Hi friends, in this video I will explain concept of symmetric cipher model, under that a simplified model of symmetric encryption for 5 marks. So whenever symmetric cipher model asked in the examination, under that we will be having the sub-component simplified model of symmetric encryption. So first of all we need to write this diagram, right? So in this there are majorly which will be containing under the 5 components, or we can say it as a symmetric encryption scheme which will be containing 5 ingredients: plain text, encryption algorithm, secret key, ciphertext, decryption algorithm. So first point is that what plain text. Plain text is nothing but whatever the user needs to send, whether it is a audio or maybe video or maybe text or maybe numbers or maybe any forms of data we need to send to the receiver. And then second is that encryption algorithm. So whatever the plain text are present, by using some substitution mechanisms, Caesar ciphers or maybe algorithms, will use any one of the method that we are going to call it as encryption algorithm. And then secret key. So by making use of this key, whatever the plain text it is present, it should be converted in the form of what? A ciphertext. And then the process of converting from a plain text to the encrypted format, the process we are going to call it as ciphertext, right? So and then once it has been sent from a sender to the receiver, this ciphertext, right? So with respect to the receiver, decryption algorithm it has to be performed. Whichever the algorithm we have used for a sender for encrypting a message, we need to use the same decryption algorithm. So that is the decryption algorithm. If you observe this diagram, we will be having a plain text input, say for example X, and then we will be having the secret key shared with the sender and then recipient, that we will call it as a K, and then we'll use the encryption algorithm. So whatever the plain text it is present, so for the time converting to the ciphertext by means of encryption algorithm, that is advanced encryption standard. So we will pass this ciphertext Y is equal to encryption of this K and then X. X is nothing but plain text, right? So and then this it has been transmitted to the transmission medium or unreliable channel, and then whenever it comes at the receiver, so whatever the encryption mechanism we operate, we need to perform at the reverse operation. So the secret key shared with the sender and the recipient, by using this ciphertext should be converted in the form of plain text. And then here we already told that reverse of the encryption algorithm it has been applied, and then we will be deriving X is equal to plain text is equal to decryption of this K comma Y. We will getting a plain text output. If any problems with respect to this K, and then we can't able to get the original plain text. So this process we are going to call it as what? Model of symmetric encryption. So here there are two distinguished terms are present. One it is a symmetric encryption, another one is a asymmetric. Symmetric is nothing but single key. One key it has been utilized at both sender as well as a receiver. And then asymmetric means two keys. So one key it has been utilized at the sender, another key it has been utilized at the receiver. So to perform this one, two requirements for a secure use of conventional encryptions are present. So first thing is the strong encryption algorithm. We need to use a strong encryption algorithm, say for example RSA or Diffie-Hellman or maybe AES or DES. We need to use the strong encryption algorithm. And the sender and the receiver must have obtained the copies of a secret key. So both the sender and the receiver, they need to obtain a secret key. These are the two requirements are present. And then if we continuation with respect to the model of symmetric crypto system, we will be having the transmission medium. Within this transmission medium, whatever the previous diagram it has been present, same thing to analyze the crypt analysis or maybe to checking onto the vulnerability present in it. So here message source X and then encryption algorithm will use it, and then key it will be transmitted to the secure channel. But here what happens? So if any third party or opponent it has been access your ciphertext, so that we are going to call it as X cap and then K cap. So this, whatever the hackers or maybe software are present, it is going to observe the pattern whether I can able to regenerate the whatever the data it has been presented. It is performing onto the trial and error method and then try to obtain a X cap and then Y cap. If it is possible, within that it will do it, and then it is going to enter into the or put into the transmission medium. If you are again decryption algorithm, it has been performed. If you get the key, and then it is going to deliver on to the destination. If any problem with respect to the keys are present, then it will not deliver. So this is what the analysis of the transmission of data in a unreliable channel. So here actually in the crypt analysis, we are going to checking onto the confidentiality and the integrity of a data should not be monitored or altered during a transmission. Thank you.